All right, so along with delta H and really cute, we can have endothermic and exothermic reactions or processes. And this just talks about where the heat is going or what the change in delta H is. With endothermic, what happens is that heat is absorbed. And so for us, this would feel cold, right? If you grab a piece of ice, it's going to feel cold because the heat is leaving your hand and going into the piece of ice to then melt the ice into water. So ice into water is an endothermic reaction. So to us, it feels cold. And vice versa, exothermic is something that's going to produce heat. And so it's going to feel warm for us. All combustion reactions are exothermic by definition, and so that's why the fire feels warm, because the reaction is releasing heat and then you're absorbing that heat. So just some example, an endothermic reaction would be something like an instant cold pack. And really all that is just ammonium nitrate being dissolved. So you just, in this cold pack, you have some solid ammonium nitrate, and then there's water around it. Then you break it open, and then it becomes an aqueous solution. And that absorbs heat, right? So heat you can think of as a reactant. It's being absorbed. And in Chem 102, you'll learn these reaction coordinate diagrams. Over here on the left side, you're going to have delta H, or sometimes it's just an E for energy. And then over on the bottom, you're going to have reaction. And from left to right, it's going from reactants to products. And so what an endothermic reaction would look like is your reactants would start off lower, and then your products would end up somehow higher. And the difference in these two heights is your delta H. But you'll notice as we're going from reactant to products, your delta H will be positive. So when you have an endothermic reaction, you will see a positive delta H. Because we're talking about what's happening to the reaction. In this case, the reaction is absorbing heat, it's gaining energy, so it has this positive delta H. On the opposite side, with exothermic reactions, we have something like neutralization reactions, which we see in lab through our calorimetry experiments. Right, so maybe something like a strong base, like hydrochloric acid, combining with or strong acid combining with a strong base, like sodium hydroxide, to form water and salt. This will feel warm, and so we can think of heat as a product. It's giving off energy. And same thing if we made a reaction coordinate diagram, our delta H/E would be over here. Reaction would go from left to right, and our reactants would start up here, and our products would end up somewhere down here, right? So as we're kind of going down, we see that we're going down in energy, we're losing delta H, and so it's a negative delta H for exothermic reactions. So endo, absorb, exo, release.